Hey Space Frontiersmen, welcome back to our channel where we dive deep into the cosmos and explore the latest in space, science, and technology. Uranus, the seventh planet from the Sun, is a fascinating world for many reasons, but perhaps the most intriguing is its unusual tilt. Unlike any other planet in our solar system, Uranus lies on its side, with an axial tilt of about 98 degrees. This means that, relative to its orbit, Uranus rotates almost perpendicular to the plane of the solar system. But why does Uranus lie on its side? To understand this, we need to delve into the history of the solar system and the unique characteristics of Uranus itself. Before we go into our explanation, we have a very small request. If you like our content, please support us by subscribing to our channel. It's a small click for you, but for us, it means a lot. Thank you. Let's begin. First, let's talk about what axial tilt is. Axial tilt, or obliquity, is the angle between a planet's rotational axis and its orbital axis. For most planets, this tilt is relatively small. For example, Earth's axial tilt is about 23.5 degrees, which is responsible for our seasons. However, Uranus's tilt is so extreme that it essentially rolls around the Sun on its side. One of the leading theories to explain this extreme tilt is that Uranus experienced a colossal collision early in its history. During the chaotic period of planetary formation, the young solar system was a violent place, with protoplanets and planetesimals frequently colliding. It's believed that a massive object, possibly as large as Earth, collided with Uranus, knocking it over onto its side. This giant impact hypothesis is supported by computer simulations that show such a collision could result in the extreme tilt we observe today. But a single impact might not be the whole story. Some scientists suggest that multiple smaller impacts could have gradually altered Uranus's tilt. This scenario is also plausible given the turbulent environment of the early solar system. Multiple collisions over time could have cumulatively tipped Uranus to its current orientation. Another intriguing aspect of Uranus's tilt is its effect on the planet's seasons. Because of its sideways orientation, Uranus experiences extreme seasonal variations. Each pole gets around 42 years of continuous sunlight followed by 42 years of darkness. This is vastly different from the more moderate seasonal changes we experience on Earth. The unique tilt also means that the equator of Uranus receives less solar energy than the poles over the course of its 84-year orbit around the Sun. The peculiar tilt of Uranus also affects its magnetic field. Unlike Earth, whose magnetic field is closely aligned with its rotational axis, Uranus's magnetic field is tilted at about 59 degrees from its rotational axis and is offset from the planet's center. This results in a highly irregular and complex magnetic environment. The reasons for this unusual magnetic field are still not fully understood, but it is likely related to the planet's internal structure and the dynamics of its fluid interior. Speaking of the interior, Uranus is classified as an ice giant, along with its neighbor Neptune. This means that unlike the gas giants Jupiter and Saturn, Uranus has a higher proportion of ices in its composition. These ices include water, ammonia, and methane, which are mixed with hydrogen and helium. The internal structure of Uranus is thought to consist of a rocky core surrounded by a mantle of icy materials, with an outer layer of hydrogen and helium gas. The impact that likely caused Uranus's tilt would have had significant effects on its internal structure as well. Such a massive collision could have generated enough heat to partially melt the planet's interior, leading to a complex layering of materials. This could help explain the unusual magnetic field and other unique characteristics of Uranus. Another factor to consider is the influence of Uranus's moons and rings. Uranus has 27 known moons, with the 5 largest being Miranda, Ariel, Umbriel, Titania, and Oberon. These moons orbit the planet in the same tilted plane as Uranus's equator, suggesting that they formed from the debris of the same collision that caused the planet's tilt. The rings of Uranus, while not as prominent as those of Saturn, also lie in this tilted plane. The alignment of the moons and rings with Uranus's equator provides further evidence supporting the giant impact hypothesis. Interestingly, the tilt of Uranus also affects its weather and atmospheric dynamics. The planet's atmosphere is composed mainly of hydrogen and helium, with trace amounts of methane giving it a pale blue color. The extreme axial tilt leads to unusual weather patterns with wind speeds reaching up to 900 kilometers per hour. The long periods of sunlight and darkness at the poles create temperature gradients that drive these strong winds and complex cloud formations. In recent years, the study of Uranus has been limited by the fact that only one spacecraft, Voyager 2, has visited the planet. Voyager 2's flyby in 1986 provided valuable data on Uranus's atmosphere, magnetic field, and moons, but much remains to be discovered. Future missions to Uranus could provide more detailed information about its internal structure, atmospheric dynamics, and the origins of its extreme tilt. In summary, the reason Uranus lies on its side is most likely due to a massive collision with another celestial body early in its history. This impact, or possibly a series of smaller impacts, caused the planet to tilt dramatically, resulting in its unique orientation. This extreme tilt has profound effects on Uranus's seasons, magnetic field, internal structure, and atmospheric dynamics. While much has been learned about Uranus, many questions remain, and future exploration will undoubtedly reveal more about this enigmatic ice giant. So, the next time you look up at the night sky and think about the planets in our solar system, remember that Uranus is a world turned on its side, a testament to the dynamic and sometimes violent processes that shaped our cosmic neighborhood. Understanding why Uranus lies on its side not only satisfies our curiosity about this distant planet, but also provides insights into the broader processes that govern planetary formation and evolution. Thanks for joining us today, and don't forget to like, subscribe, and hit the bell icon to stay updated on all things space and science. Until next time, keep looking up.